Okay, this will be the Class 2 video for Stata Education 401B mainframe. I am Ben. And just to orient ourselves, here we are in the 401B mainframe. I've added the content for Class 2 down below. I'll link to the video when we're through here. What we're going to walk through is the exercise, and the exercise is going to be us talking about a handful of new concepts, which I've listed here. And they're going to feel a little bit isolated or a little bit on an island. We're going to talk about them one at a time. And then the activity for the week I'm excited about because I think it'll bring together these concepts in an interesting way and in a context relevant way. I've wanted to respond to the feedback. I've created this reference sheet, and for each class I'll include valuable commands that you can look at. Very often you just need a simple example of a command, and this reference sheet can be that. You're welcome to comment on it, add your own commands, do what you will. I want this to be a valuable class resource, but I'll be looking at this throughout and show you how I'm using it. I've got Stata open here, and on my desktop I have each of these CSVs, and we're going to use each of these for the different concepts that we're going to cover. And your task is literally to do the same thing with the same data files, but to make sure you're understanding what's happening and making sure you can execute it on your own. So all I did was I opened Stata. Let's get a do file editor out here. And then I love getting the half pane. And the first thing we're going to cover in the exercise is examining duplicate values. And so what I'm going to do is, very first, you're going to notice I've got my data on my desktop, and so I want my working directory to be my desktop. And so this is one of those things that we actually have a command in the dropdowns for. And I went to File, Change Working Directory, and then I chose my desktop. And what happens is that sends a command. That's just a shortcut to send this text command. But I want my do file to be comprehensive of everything I've done. So anytime I cheat and I go use these to figure out what command I need, I'm going to copy and paste it. And you know it's what I did. It's got a period before it. And then afterwards is what the computer responded with, which is, it told me where we now are. And so I can run it. I get responded with. So what I want to do is I want to import data, and I want to import duplicate files. So I'm always going to start with a comment. If I do the asterisk sign beforehand in my do file, that's a comment. The computer's not going to run that. If I try to run just this line, nothing happens. It just runs the star, but it's not. It knows that's human language. That's a comment. And so I'm going to use the import as another way of cheating. And we'll see how we can do this in the future without. But if I do, I went to File and then Import, and I've got CSVs over here. Pay attention to the extension. We'll often use CSVs. That's a very common data format. And it says File to Import. I'm going to go to Browse. I'm going to choose Duplicate Values. And it gives me a preview here. The preview looks good to me. And so I'll copy and paste that over again so that I have a running collection in my do file of exactly everything I've done. Anytime you pull a data file in, it's always good to look at it. You can click Data Browse up here to do that, and you'll pull it up. Another way to do it is to type the command browse, and if I then run just that command, it'll pull up the data browser. And so what we're going to see here is I've got this one variable in this data set, and the variable takes value 1, then 2, then 2, then 3, 3, 3, 4, 4, 4. And what I want to be talking about here is very oftentimes in data analysis, you are wondering how many times a value shows up, how many duplicate values there are. And so maybe think about it as this variable stands for student ID, and you think you should have each student show up exactly once within the data set. It wouldn't make sense for them to show up multiple times unless you had a data entry error or something like that. So we're interested in duplicate values and how many times they repeat. So here I've got a duplicate of 2, 2 duplicates of 3, 2 duplicates of 4, and so on. So if I go here, reference sheet, I've got this import data thing. I've got duplicates. And so I'll copy and paste this over duplicates list var name. And so how I've written this command is duplicates list is actually the command. This first word is like a class of commands, and then list is a specific one. And then here I need to replace the actual variable name. And then variable name here is variable. And so if I run this, it's going to give me a little summary of my duplicate values. And so this might take a second. I find this to be a little unintuitive to read. But we can think about this. So observation 2, variable 2 happens twice. Observation 4, 5, and 6, variable 3 happens 3 times. And so I'm trying to think, how do you read that? Group 1, 1, 2, 2, 3, 3. It's a little bit confusing to read. Oh, it's okay. So this variable actually corresponds to the variable. So see, it's giving me all the ones that have duplicates of this 2, 2, 3, 3, 3, 4, 4, 4. And then it's giving me the observation number, which is the row number 2, 3, 4, 5, 6, 7, 8, 9. And then it's numbering the groups they come from. So it's giving me all, it's summarizing all of the variables that have duplicates, which we can see here is 2, 3, and 4. I find that to be a little unintuitive. You can tell by me pausing and after figuring that out. There's a duplicates, instead of list, I can do duplicates report variable. So again, how you read this is duplicates is kind of a class of commands, and then you can do different things, like a sub command is report. So if I run this, I think we're gonna get something I find to be more intuitive. Okay, yes, this is much easier to think about. So there are 6 variables where we only have one of them. That'd be 1, 0, -1, -2, -3, -4. We have 2 variables, 2 observations and 2 variables where we just have 2 of them. That's the 2, and the surplus is we have 1 extra one there. And then 3 copies, there's 6. There's 3, 3, 3, 4, 4, 4 makes 6. Surplus is 4 because I should only have 1, 3, and 1, 4. So that's a duplicates kind of thing. You can dive into that. I'll show you how we get help. I did help and duplicates, and you can see that there's other commands. You can do duplicates report, duplicate examples, list tag. Let's do duplicates examples. So if I do duplicate examples, it's going to give me examples of the variable 2, 3, and 4 again, and it marks the where it's getting the 2, 4, 7. So this call this the observation. Okay, so that's a little primer on duplicates, the kind of the reporting that happens. Now let's do something else. So the way Stata works, it always has exactly one data set loaded into it, and you can always see that by doing the browse or looking at the browser. And sometimes you don't want that though. Sometimes you want to go back to having a fresh slate. To do that, all you do is do clear. So if I run the clear command and then go to data browse, I now don't have anything in there, which is great, which is really, really great. And so the next thing that we're going to do is the idea of a merge or a join. And so this is very, very important. Now let's do merge. And to show you what I mean, I'm going to open up these 2 CSV files, merge 1 and merge 2. I'll zoom in here. So in merge 1, I've got the name of a person, and this is merge 1. I've got the name of a person and then their mother. Ben's mother's Joyce, Bob's mother Mildred, Billy has Marion, and Casey has Krista. Those are all female names in my family, of the older variety. And then I have this other CSV where I've got name and then I've got sister. So Ben doesn't appear in merge 2 because he must not have a sister. It's actually not true, I do have a sister, but Billy shows up twice because he has 2 sisters, and so on and so forth. And so we want to take these 2 data sets and merge them together or join them together into one data set. And the first thing you probably want to think about is, what do we want that data set to look like? And we can just brainstorm here. Certainly we want the name of the person, and then we're going to want their mother, and then we're going to want their sister. And so let's start with Ben here. Ben, mother's Joyce. Sister, he doesn't have one, so I'll leave it blank. Let's move on to Bob. Bob's mother is Mildred. And Bob has a sister, Katie. Let me bold these just so you know they're the variable names. And so that's Bob. Now, Billy is where things are going to get interesting. Billy's mother is Marion, and Billy has two sisters. Billy has Emma and Emily. And so I've just shown you one way that you could store the data, where you maybe separate these by commas or pluses for any time you have additional information. But what's actually much more common is to keep everything in this kind of one row format. And instead of doing a plus or something, you'll actually make a new row. So now Billy, because he has two sisters, will have two rows in the data set. And Casey, similarly, will have three. So it'll be Casey, Krista, he's going to show up 3 times there. And then he's got Amy, Alex, and Alex twice. So this is the kind of way that the data set probably wants to look once we merge those two things. And our task right now is to figure out how to get Stata to do exactly that. So let's tackle that. Let's totally tackle that. The hard part about doing this in Stata is, like I said, you only can have one data set open at a time. And so you're going to load one into your memory and then combine it with a different one that's not in your memory at the time. And the trick is you want the one, you can do it either way. The way I think about it is you want the one where there's multiple values per person to be the one you save first. So because the sisters have multiple values per person, I'm going to first pull in sisters and save it. And you'll see why we're going to want to do that. So I'll use the import again. CSV, we're going to browse for merge 2. That's the one with the sisters. Let's open it. You see it's getting confused here. It's confused about a couple of things. But first, it's not taking the variable names as name and sister. So use first row for variable names. I'm going to do always here so that I actually get those variable names to work. And you're going to see how that changed this command. It basically added another var names of 1 here. And now let's do a browse on this. You're going to notice something not great here, which is I have this Unicode character, this weird thing that's showing up. I don't want this to be I don't even know what that symbol means. I'm curious if you know. But I want to rename name to be name. And so to get with this weird character, I didn't know what it was, but I just copied it from up there. And now if I run this rename thing, I'm going to get, it's going to be back in a format that I like, where the name and the sister look good. Okay, and I want to save this. So I just so take a look. Rename because we had a weird variable, and now we want to save it. And so, okay, we can always do this with words or with text, but we can also just save it like this. And so I'm going to call this merge 2. And Stata uses what are called DTA files. I'm not exactly sure what that stands for. Stata data, I guess. DTA is kind of like data with 1 less A than it actually has. So I'm going to save it like that. And when I save it, I still have it in my memory. Because it saved it, it didn't leave. It just saved the file as it always does. So let's keep this command. And now we need to clear. So I'm going to do clear, which is going to, again, now I have nothing in mind. And now what we're going to do is we're going to load into our memory the data file that we want to join it with. So load other data file. And I'm going to do something here, which is I already know that this is going to be the command I need, except for on my desktop, this is called merge 1 and not merge 2. So I'm just going to replace this. And that right there is why using code like this becomes really valuable because we're literally doing the exact same thing except we just changed one little number there. So if I run that and then browse, I now have it there. Again, I have this problem, but I have the exact code to use to fix that problem. Rename this I name as name, run it, and now I'm fixed. So I have the name in the mother file open. I want to merge it with the name in the sister file, which I've saved to my desktop. And so I'm going to go up to, I know it's up here somewhere. Maybe is it data editor? No. Combine data sets, merge two data sets. That's exactly what I want to do. I have two data sets, one with mother, one with sister, and I want to merge those two together. So we're going to have a few things we need to think through here, a few options. 1-to-1 on key variables. That would be if there was exactly one name in each file. That's not the case, remember, because each name, the key variable is the thing that's going to cross-reference the files from file 1 to file 2, and that was name in this case because it's the consistent column. But the sister one, the one on disk, has multiple of those. So 1-to-many on key variables. For each name, I've got one variable in memory, unique key for data in memory. This is unique because it's only one of them. And then the many is going to come with the file that's on my disk. And so this, I want to go 1-to-many because I've saved that. Key variables, it's name. That's what we're going to match it on. I wanted to search for Ben in the other one. And then I need to choose the file. And you notice I had to save it as this data file because it doesn't take CSVs for this purpose. So I'll open that. I have everything set up in a way that's, I think, correct. The valuable thing about using this small example is that if I got something incorrect, I'll be able to troubleshoot it and look back and figure it out. So I'm going to click OK. And some magic happened. Well, I can see it in my data file, something happened. I can also see, let's write down this command so I can have this Stata file. Let's make some room and zoom down here. So that's what I did. And you can kind of look at this command and see what we're doing. 1-to-many, using name was the key variable, and then using this data set. It tells me where I got my matches, which was not matched. One was not matched. That was the kid without the sister, Ben. And then which ones were matched. And now my data file looks like this. It looks exactly how we would have expected it. It's not ordered. Casey shows up here, here, and here, but we can figure out how to order it. We talked about that before. And then I also have this merge column, which keeps track of where it came from. So master only means this was the master, the original, and it only came from the master. And then matched means, oh, we have values from both of the data sets that we got them from. And so that's the basic idea of a merge. I want you to play around with that and see if you can replicate that in different ways. One challenge you might do is actually save merge 1 and then merge using merge 2 in your memory, and you'd switch, and instead of being 1-to-many, then be many-to-1. So that's one thing to talk about. So that was the idea of a merge join. Next thing we're going to do is calculate correlation. So now let's do correlation. Again, I'm going to clear before I do anything. Cleared it out. And I want to load in a data set. I want to load in correlation.csv. Thankfully, I already know this is what I want. I know I just need to swap out this. It's on my desktop. Varnames 1 means they're going to use the first row as the variable names. Open it up. And again, I have this weird Unicode thing. I'm not sure exactly why that's happening, but we can always fix it. It has a consistent thing of rename that thing that's the weird I with the X. We'll call it X. That fixes it. So I have X, Y, Z now. And correlation is the degree to which variables move together. And so what I'm going to do is I'm going to make a scatter plot matrix. I'm going to do it with, I can choose the variables that I want to do. So I'm just going to type X, Y, and Z. You can choose them from the drop down as well. And click OK. And so we can steal the command here. And I can look at, where'd that scatter plot make it go? Oh, there it is. Come on, I'm running around with Windows right now. Windows is going everywhere. But I can look at this X, Y, and Z. So this plot right here is with Y on the X-axis and X on the Y-axis. That's kind of confusing. And plots the values. It plots the different values. This graph, so this is X on the Y-axis, this is Y. This is the same graph, but now X is on the X-axis in this one, and Y is actually on the Y-axis. So if I looked at my data, 1, 2, this is X equals 1, Y equals 2. Then I go up to 9, 9. This is X equals 9, Y equals 9. You can see these follow this line. This one is 6, 10 right here, X and Y. Here, let's look at this one, just make sure we're interpreting this. Z is 6 and Y is 4. That's this point right here. So we're looking at all of these pairwise relationships between these things. And what correlation is going to do, it's a number between -1 and 1 that tells you the degree to which a line fits that data. The degree to which a line fits that data. And so with all of these, it seems like a line's going to fit the data pretty well. This one feels pretty strong. This one's going to be negative and a little less strong. It's going to be negative as well, it seems. So let me just look at the reference sheet and remind myself how to do correlation. Okay, so it's PW core, pairwise correlation, and then I can do the different variable names. And so it's going to be X, Y, and Z for my variable names. I run that, and now I'm going to be able to look at this. So on the diagonals, X correlated with X is always 100% correlation. Of course, something with itself is a perfect relationship. They lie on the line. But then I can look here at, what about X and Y? So X and Y is this. There's a 0.9 correlation between those two variables. A line fits it very well. It's positive because it's positively sloped. So it's close to 1 because it fits it really well. X and Z is -0.75. Doesn't fit as well, no thanks to this line, or to this point, and it's negatively sloped. So this doesn't fit as well as this does, but it's still pretty strong. But anything above a magnitude of 0.5, greater than 0.5, or less than -0.5, is a reasonably strong relationship there. And so that's a cheap way, or a quick way. I wouldn't say cheap, nothing cheap about correlations. Not what we're paying. That's a terrible joke. But it's an easy, quick way to think about it. One word of warning I have in the exercise, I have an exercise here. There's a couple of images we can look at. So if you want to get a sense of like what the values mean, perfectly positive, perfectly negative, falls straight on a line. No correlation, is they're just scattered everywhere. But you've got to remember we're living in a linear world, and the degree to which your data lives in a linear world is probably up for debate. And so we have these examples from Wikipedia, or maybe Wikimedia, where you have these different correlations here, but then down on the bottom, these zeros, these are all data sets that have zero correlation in them. And you might pause and be like, that seems weird because it looks like there's relationships. It looks like if you know X, you could predict Y pretty well, but you couldn't predict it well with a line. A line, the best line you could draw would be horizontally straight across in any of these, despite what looks like a visual relationship. So we always need to keep in mind that correlation deals with linear relationships in this case. And that's something to be aware of. Okay. You'll see that in different data sets. So let's talk about t-tests now. We'll whiz on through t-tests. So I'm going to, again, clear. And I've got a file on my desktop, t_tests. Which I will load in. Treatment got messed up. So let's do that little rename trick. And actually, I'm going to rename it. But actually, for this data set, just for now, let's actually just, I'm going to drop. So this drop command just removes it. We're not even going to think about this for now. Think about data structured in that way. And so what a t-test does is it compares the means of two different sets of values. So in the variable x, we've got some numbers. In the variable y, we've got some numbers. And it looks to me like the values of y are greater than the values of x. That just appears to be true. It's 5 bigger, 2 bigger, 4 bigger. And I've actually made a variable that summarizes this: 0 bigger, and 6 bigger. So it's always as big or bigger. And the thinking behind the statistics here is, well, yes, those values are bigger, but are we sure it's not just due to random chance? Are we sure that y didn't just get lucky? We only have 6 data points after all. Are we sure y didn't just get lucky in being larger? Or maybe being smaller is better. Maybe x got lucky in being smaller. But are we sure it's not due to random chance? And t-tests allow us to say, hey, let's assume that they're the same. What would be the probability of seeing something this crazy? How crazy would it be to see something this crazy? And it allows us to actually get a probability on that. And then we do some statistical inference based on that probability. And so let's check out the reference sheet. So for a paired t-test, t-test x equals y, very convenient because those are actually the exact variables that we're using. So what do I mean by paired t-test? What that means is that this 4 and this 9 go together. It means they're a pair. It's like this was a test score before, this is a test score after. They're connected in some way. It's not that these are just in some sort of random order. And it turns out that changes some of the assumptions in the way things go. So if I run this, I get a lot of information. And I can put it side by side with the actual data because I think that'll be useful to look at. There's 6 values of x, there's 6 values of y. The mean of x is 5.16, the mean of y is 8. And so this difference, it deals in the first variable minus the second, so it's negative 2.83. This difference is negative 2.3. We're wondering if that's different than 0. That's H naught, the null hypothesis. Is this difference equal to 0? We're wondering. And to cut to the chase, we're going to do a two-sided, so we'll pay attention to this one right here, which basically said, going in, we don't know if it would have been bigger or smaller. We're not sure if they would have been larger or smaller, so we're just looking at, and we get a p-value here of 4.24%, 0.04%, or 0.04 or 4.24%. And that says there's only, if the means were actually equal, there's only a 4% chance that we'd see something this crazy. This is a pretty big difference given that the values are 5 to 8. That's a significant difference. It feels significant. And so anytime this number is less than 0.05, we do what's called, we reject the null hypothesis. But basically the intuition is we say, okay, this difference is big enough where we don't think it's due to chance. And that's what a t-test is. Variable equal y. Stata makes this very easy to run. You'll also notice that there's another variable in here, y minus x, and there's a different type of t-test which just compares a variable to some mean that we can come up with. And so that's called an independent t-test. And so what that's going to do is say x equals 0. This is going to test if the mean of x of 5.166 is it different than 0? Is it above 0? Almost certainly that's going to be yes, because all the values are significantly above 0. And we get that, 0.0013. But where this gets interesting is we had run this t-test x equals y, and we said, hey, is this smaller than this? Is there a difference here? But you can pause and think about to yourself, that's pretty much the same thing as seeing if the difference is greater than 0. And so I can instead run an independent t-test where I check if the difference is greater than 0 or not. And I'm going to show you that I just ran the paired t-test. And remember, our p-value is 0.0424. Instead, if I do this independent on the difference, I'm going to kind of magically get the same information. I'm moving the opposite direction, so 2.83 and negative 2.83 just depends on which one you consider subtracting from the other one. But the important thing is this mean is the same, the standard error is precisely the same, the standard deviation is precisely the same, and this value, this percentage that we're going to really care about, 0.0424, is exactly the same because this is mathematically equivalent. And so those are two different tests that will pop up, and I'm going to have you use them in the in-class activity, and hopefully that'll cement those in your mind, the degree to which you've been familiar with t-tests in the past or not. So let's move on to the last thing, which is going to be create an indicator variable and then sum it up, and creating indicator variables. So again, when we want to do something else, we're going to clear. And so, what's the name of this? Summarize, it's funny to answer questions to YouTube videos. Summarizing underscore indicator. So let's do that. Summarizing I run that. We can type browse, which will pop it up and let me look at it. Oh, I've got this darn problem again. Rename. There's got to be a simple, there's got to be like a setting or something to fix that I'm just not aware of. So X and Y. And so this is a really small data set, but what you might sometimes wonder is how many values of X are greater than 0? Well, the answer is 3. You can look at this very easily. But what if this was 16,000 rows long? You wouldn't be able to just look and count. It wouldn't be so simple. And so there's a simple idea of creating an indicator. And then summarizing it. And so let's do that. Let's see if we can get the answer of 3 for X by actually doing it programmatically and getting the computer to sped it up. So the first thing I'm going to do is in this gen line, I'm going to over 0. I'm going to create a new variable called over 0. I'm just going to run this line. And it's going to tell me if X is greater than 0. 1, yes. 3, yes. 2, yes. Negative 2 is no, so it's a 0. And now all I want now is I want to know the sum of these. I want to know the sum of these values. 0, 1, 1, 1. I want to know the sum of those values. And remember, this sum stands for summary, not sum, which is misleading because I'm looking for the sum right now. So if I run this, I get a lot of things. I get the number of observations. I get the mean. Pause, challenge for you. See if you can remember why or think through why this 0.75, the mean, is actually the percentage of values greater than 0. I'm averaging 0. I'm summing up the total number of times that it's greater than 0. I'm dividing by the total number of observations. So this 0.75 equals 1 plus 1 plus 1 is 3. Divided by a total of 4 observations, 0.75. But I said let's find the total, not just the mean. And so this sum didn't do it. Nowhere in here do I get 3. I want 3. Turns out to be 0.75 times 4, but that doesn't work. So there's these extra options in Stata, which is after you do a command, I can ask for something new. I can say display, just show me something, and then R. I don't have a reason for the R, but we'll memorize it for now. And then sum is actually saying give me the sum. So if I run that, now I get the 3. Now I get the 3. Now it actually gave me the sum. It displayed the sum from the data set from the previous command. But remember, it's important. These 3 commands must be run in order. Must be run in order. I have to create the variable. I need to summarize it. And then I need to say, give me something more. It doesn't work like that. So create the variable, summarize it, and give me something more. Similarly, we can do something. What if we want to know when x is less than or equal to 1 and y is greater than or equal to 2? Sometimes when they get complicated, I'll just call it an indicator. I made over 0 be something. And so this is going to be when x is less than or equal to 1. In Stata, to use an and, you use the symbol, not typing it. So it's shift 7. And then y greater than or equal to 2. That should generate an indicator. We can check it. X less than or equal to 1, that makes sense. Y greater than or equal to 2, yes, yes, yes. 1, 1, 0, 0. Makes sense? If I do a sum, I'm going to get this information. Lo and behold, the mean is 0.5, which is the percentage, 50%. And then if I do a display, I get the total, which is 2, which is that. So this is the idea of creating an indicator, doing some summarizing as a way of getting Stata to kind of sneakily calculate something for you. Looking forward to seeing you in class. Engage with this stuff, and you're going to be in a great spot to engage with a fun activity in class.